Hey guys, we are on day 4 of Unit 2. We have just skipped day 2 and day 3 due to the pandemic and our shortened school year and instructional days. We've cut out a couple topics that we taught but didn't have to. They're not in the curriculum. They don't show up on the exam. So we're going to go ahead and skip over those, but we're still going to cover the ones that do show. So this is fractional equations. And the first question on fractional equations is what's the difference between an expression versus an equation? And hopefully you guys know that equations have to have something that expressions don't. And we're going to say that equations must have equal signs. Expressions don't. Okay. Next bullet says, since we are solving fractional problems, are there any times that solutions would not be allowed? And the answer is yes. If you remember from the first day of notes, after we did simplifying, we talked about when fractions are undefined. You are not allowed to divide by 0. And therefore, if a solution turns the, oops, that's not how you spell turns the denominator into 0 when the solution is plugged in, that solution would not be allowed. And when a solution is not allowed, what do we have to do to it? We have to reject it. Okay? And so that rejection, that solution would actually be called extraneous. It's an extraneous solution. It's still a solution. However, because it gets rejected, it's an extraneous solution. Okay, so just letting you guys know what it's called. All right, so next question says, what procedure would be used to solve the following problems? And there's a couple ways we could solve these, but the easiest way, as soon as you see a fraction equal to a fraction, we cross multiply. Okay, and that's only when you have a fraction equal to a fraction. There must be that equal sign in between the two fractions. If there is not, you cannot cross multiply. Okay, so here we go. We're going to go ahead and get this cross equal to that cross. And so we have an x times a 2x equal to an x minus 3 times an x minus 2. And you'll notice why I wrote that because of this cross right here. A lot of people don't realize that's double distribution. But if I put them together like that, I think that that will help you realize that that is a binomial times a binomial, and you'll have to do double distribution, or some of you use the little square, and you guys can distribute and get your terms in the square instead. All right, so x times 2x is 2x squared equal to, this will give you x squared. This will give you minus 2x. This will give you minus 3x. And this will give you a positive 6. Again, if you want to distribute and use your little square and set it up, you're more than welcome to. Okay? You would have got the same 4 terms that we got. Okay, so I'm going to go ahead and clean up that one side because it looks a little messy. So we're going to keep the 2x squared here for now, equal to that x squared still. But this will give me a minus 5x and then a plus 6. All right, since we have a squared term, hopefully you remember from geometry that means we're going to have 2 answers. We're not going to get the 2 answers, though, unless we do something called factoring, and we cannot factor unless we are equal to 0. Remember that when you factor, your squared term should be positive. It doesn't have to be, but it's easier to factor, makes it an easy trinomial when it is positive. Okay? So it is easier to move the 2x squared. However, you can foresee that you'll end up with a negative and then you don't want it. So I'm going to go ahead and subtract this x squared and bring him over here. They'll be gone. I'm going to go ahead and take my 5x and add him to this side, and then he'll be gone. I'm going to go ahead and subtract my 6, put him over here, and then he'll be gone. And now I got to see, what do I have left over here? 2x squared minus x squared is just x squared. And then I have that plus 5x. And then I have that minus 6. And there's nothing on the other side, so we can say equal to 0. And now he looks like a nice trinomial, and so we'll go ahead and xbox him. Our multiply is -6, and our add is +5. And we're going to say that the numbers are 6 and 1. They could also be 3 and 2, sometimes 6 with 6 and 5 on the top and the bottom of your xbox. It's hard, so you really have to make sure your numbers work. In order to get a 5 out of 6 and 1, I'm going to say that that 1 has to be negative. And so that multiplies to the -6, and it would add to the +5. So I have the right numbers. Why wouldn't 3 and 2 work? Let's see. In order to get a +5, 3 and 2 would have to be both positive, but then that would give you a +6 when you multiply them, and that's why it doesn't work. Okay, so he's an easy trinomial. He gets broken up into an x plus 6 and an x minus 1, and we are equal to 0. And now we're going to do this t-chart. And so we're going to take this x plus 6, and we're going to set it equal to 0. We'll take the x minus 1, and we'll set it equal to 0. Okay, I'm going to move this up a little bit so we have a little bit more room. And over here, we're going to go ahead and subtract the 6. And when we do, we end up with x equals -6. Over here, we're going to add the 1. And when we're done, we get x equals +1. And we have 2 answers. And hopefully we can keep them. What we're going to have to do is we're going to have to go back here. And we're going to have to look at our denominators. If this lets me erase so I can see my denominators. Nope, maybe not. All right, so, it's not letting me erase now. Okay, so if I erase so I can see my denominators, if I take one of my solutions, which let's say is -6, and we plug it in, -6 is an okay denominator because it's not 0. Over here, -6 minus 2 would give me a -8, and that's not 0. And so -6 can stay. Okay, that is a solution, and we keep it. Let's see about the 1. If I go back and take a look at my denominators up here, okay, but this time I plug in my 1. Having a denominator of 1 is completely fine. It's not 0. If I put the 1 in here, 1 minus 2 is -1, and that's also not 0. And so both of my solutions can stay. Then neither one of them make my denominator 0, and so I don't have to reject them. Okay, let's try another example. Again, we have a fraction equal to a fraction, and so we're allowed to do something called cross multiply. So we get this cross equal to that cross. So we would have an x times an x plus 2 equal to a 2x times an x minus 2. Okay, here we just have single distribution. X times x is x squared, and x times 2 is 2x. Equal to, single distribution here as well, 2x times x is 2x squared, and 2x times -2 is -4x. Again, we have square terms, which means we're going to have 2 answers when we're finished, but we won't get them unless we do a process called factoring, and we cannot factor unless we're equal to 0. And remember that when you factor, you want your square term to be positive. So with that in mind, if you can foresee, I'm going to go ahead and move these terms over here so that my square term stays positive. Okay, I'm going to go ahead and subtract the 2x, put them underneath here, and these are gone. Okay, so what I have left is 2x squared minus x squared, which is x squared. -4x minus 2x is a -6x. And I have nothing on the other side, so it's equal to 0. Okay, that is not a trinomial. However, remember the first type of factoring we should check for is greatest common factor, and there is an x in common, so we're going to pull it out. And what we have left is an x minus 6. Okay, And so what we're going to do is we're going to take each factor, this factor of x, and we're going to set it equal to 0. And we're going to take our other factor of x minus 6, set it equal to 0. This one's already solved. However, this one we have to add 6 so that we get our second solution of x equals 6. Okay? Now what we have to do is we have to go back up and we have to double check that our solutions don't make our denominators 0. If they do, they have to be thrown out. So let's go ahead and take our first solution of 0. And as soon as I replace that x with our solution of x equaling 0, right there, that has to get thrown out. We are going to go ahead and reject this. He cannot stay. He makes that fraction have a denominator of 0, which means you're dividing by 0, which is illegal in math, and so we're going to reject. And sometimes I like to write the reason here. It's just undefined. That answer makes my first fraction undefined, and so that's the reason why I'm rejecting it. It actually would also make my second denominator 0, right? 2 times 0 is 0, and so that would be another reason to reject it. Let's go ahead and look at our second solution, which is 6. And so if I erase this instead of drawing on it, okay, but my second solution is 6, and so a 6 being here, absolutely fine. It's not 0. And then 2 times 6, this would give me a denominator of 12. And again, completely fine because it doesn't turn my denominator into 0. Okay, so this one can stay. We checked him. All right, so going on the bottom, we just talked about this at the top, about solutions that are rejected, and they are called extraneous. Extraneous solutions. And we had our first extraneous solution right here. Okay. Now what happens when you can't cross multiply to solve? Okay. Well, you could put the two fractions together by adding. However, adding two fractions together would give you would need a common denominator. And in order to do that, if you remember all the way back from whenever you started adding fractions, probably in 5th grade. However, we have a little bit of an easier way instead of, getting and adding just the two fractions together and then cross multiplying. We have a little bit of a better process. Okay, so thought process. What do you need when you add or subtract fractions? And we're going to go ahead and say common denominators, which means the denominators have to be exactly the same. Okay, and you do that by multiplying the top and the bottom by a certain number that would make the bottoms the same. How can we get rid of the fractions so the equation is easier to understand and solve? What we're going to say is that if all the denominators are the same or equal, then the numerators must be equal. Okay? If all denominators are the same or equal, then the numerators must also be equal. Okay, and then it says, do I still need to check at the end for extraneous roots? And if there is an x in the denominator, then yes. If there is x in the denominator, yes. Okay, so there's an example up here to solve the equation below for x. And so if I look at all the denominators, 10, 5, and 2, they're not all the same. And so because they're not all the same, then that means we can't just ignore them and look at the numerators to make them all the same. So what we're going to do is we're going to come up with a number that represents the lowest common denominator. You always try for the lowest common denominator. And the lowest common denominator is also known as an LCD, lowest common denominator. And when people say lowest common denominator, they always think, oh, I'm going to look for the lowest number. Well, you are going to look for the lowest number, but the lowest number that all of your numbers in the denominator go into. So a lot of people are wanting to try to make them all 2s. So you can't make them all 2s. You actually look at the highest number and try to make them all that. So all of our numbers, 10, 5, and 2, all go into the lowest number. And the lowest number here is actually 10. And so now we have to use multiplication to make them all 10s. So what is, I have to multiply 5 by to make it a 10? And the answer is 2. But if you multiply the bottom by 2, rules of a fraction is you have to multiply the top by the same number. Okay, you're really multiplying by 2 over 2, which is the same thing as 1, and multiplying by 1 doesn't change it, and that's why it works. Okay, what do I have to multiply 2 by to change it into a 10? You have to multiply it by 5. But if you multiply the bottom by 5, you have to multiply the top by 5. Okay, and so now what we have is that we have x over 10 plus 6x over 10 equal to 35 over 10. And so this is what we need. If the denominator here and the denominator here are the same, then the denominator in your answer is the same as those. And that's how adding fractions work. And so since they are all the same, then their numerators must all be the same. And now all we have to do is focus on solving x plus 6x equals 35. So notice how getting that common denominator makes the question 100% easier. X plus 6x is 7x. And when we divide by 7, x comes out to equal 5. And notice that there are no x's in the denominators, therefore we do not have to check. And we have our x equals 5 answer. Okay, now you could plug it back in and check, but you do not have to. Okay, all right, I'll see you guys on the back side of notes.